Electricity is always one of the difficult questions in A-level physics. So look at these questions. A cell of negligible internal resistance is connected to a network of resistor and a voltmeter as shown. So when the students look at these questions and we look at the diagram, you'll get confused. They never learn this kind of diagram from the teachers. Okay, so one important information from this question is the reading on the voltmeter is 0. So what is the resistance of the resistor R? Let's look at how to solve these questions. I would suggest that you redraw the circuit. So by transforming the circuits into some parallel circuits, and it will be easier for you to solve it. So let's transform the circuit. So you have the voltmeter here. Okay, and then you have the other part of your circuit here. 14.4 ohm. Your resistor R. So they are in parallel. And then there's another parallel resistors here. Okay, and then this is your EMF. Let's the EMF to be E for these questions. All right, so what they tell you from the question is the voltmeter give you a reading of 0 volt. So which means that if you draw a loop here from this point back to this point here, it gives you the V equal to 0 volts here, the potential difference equal to 0 volts. So if we let the potential difference across the 2 ohm resistor as V1 and this to be V2, so we will know that V1 should be equal to V2, but they should arrange in the opposite direction. What I mean here is you put a sign of the current flow. This should be positive, negative. This should be positive, negative. So when you break the branch, so it should give you something like this. So your 3 ohm resistor here, and then your 2 ohm resistor here. So we take this point as A, take this point as B. So if you read from the A, you have negative, positive, and you have positive, negative. So this is your V2 and this is your V1. So negative V2 plus, so you read it from the top to down. You have negative here, so it's negative V2, and you have a positive here, so it's a positive V1. Should be equal to 0 because they tell that here is 0 volt. So you have V1 equal to V2 as your first equation here. Okay, this is the first steps that you have to do for this question. The second step will be look at this branch here. So this branch here, let it to be X and Y. So for the branch X and Y, you have 2 ohm here, and you have another 4.8 ohm. So they are in series. So this XY, you should have a total potential difference of E. So which means that if this is V1, so you can form an equation of V1 in terms of E. So your V1 should be equal to your potential divider equation. Resistance is 2, and the total resistance is 2 plus 4.8 times E. So your V1 should be equal to 2 over 6.8 E. Okay, the third step here is to go with the, let's the branch here to be PQ. So they are parallel, so they should have the same potential difference as well. So if you redraw the PQ, so you have your 3 ohm here as your V2, and then you have your 14.4 ohm, and you have your R here. So we don't know what is the resistance of R, but we let the parallel resistance here as RP first. So for this one, their potential difference will be E as well. So your V2 should be 3 over 3 plus parallel resistance times E. So this is your first one, this is your second. So we should solve this together because we know that V1 should be equal to V2. So when V1 equal to V2, so 2 over 6.8 times E should be equal to 3 over 3 plus the parallel resistance times E. So by solving this one, you should have the parallel resistance as 7.2 ohm. So solving this parallel resistance or parallel branch, 1 over R plus 1 over 14.4 should be equal to 1 over 7.2. So if you rearrange, you should get 1 over 7.2 minus 1 over 14.4. So 1 over R should be 1 over 14.4 as well. So your R should be equal to 14.4 ohm. So this question is slightly complicated, but if you do it step by step, you should still able to solve it. R equal to 14.4. Answer will be D here.